I'm Jessica. I'm here with Nate and David from Watershed as well. We're all engineers working on mostly on sort of carbon footprint measurement. That is a lot of Watershed's core business. So excited to share a little bit about with you today. So I'm going to go over sort of what Watershed does, because you might not have heard of us necessarily. Talk about the kind of asynchronous work we do at Watershed, some of the problems we had with that, and why we ended up using Temporal as a result. And sort of walk you through an example of a carbon calculation that we actually sort of use a decent amount of workflow orchestration to do. So Watershed was founded on sort of the idea of fighting climate change. We have to make really meaningful progress towards massive emission reductions by 2030 in order to avoid the worst consequences of climate change. And Watershed was founded on the idea that businesses are actually pretty major actors in helping move the planet towards a net zero carbon future. So to that extent, we partner with companies and we empower their climate programs. So we have a bunch of customers from software companies like Airbnb and Stripe, to food companies like Imperfect and Sweetgreen, to apparel companies like Everlane, where we help them sort of measure their carbon footprint, figure out what to do with it, reduce it, and make reports on it, and sort of like basically action their entire climate program. So through our customers, we manage over 24 million tons of carbon, which is actually over 5 times the carbon footprint of the city of San Francisco, which kind of validates the idea that Watershed can make most of its impact through businesses. 45 of our customers have already announced climate plans to be net zero by 2030, which is sort of the gold standard. And with all of this carbon under management, it actually ends up meaning that data workflows are actually really core to our value proposition. So I'm going to talk a little bit about what exactly that looks like in terms of the asynchronous workflows that we write at Watershed. So for the first piece of this is carbon data correctness. Through carbon data and computation, we perform a lot of emissions estimation by converting basically a business's activity data to carbon. So figuring out how to model this data, keeping it up to date, maintaining invariance, and testing it is sort of it's not something that's been done a lot before in the past. So we have to figure out how to deal with that. And a result of sort of this kind of data is that we actually operate on medium-sized data, so not quite terabytes, but sort of small gigabytes of data that often fits in memory. So sort of our library of carbon data is not ginormous, and neither is our customers' data for the most part. So it's often sort of medium-sized data that we can usually load in memory, don't have to distribute quite fully, but it's still sort of significant. And another interesting thing about the kind of asynchronous work we do at Watershed is that we actually have both short and long running tasks that are sort of like asynchronous. So we have some tasks that are interactive in the sense that, like, for example, a data analyst is waiting on the other side for the workflow to finish. But some tasks that are like much more long running. So sort of anywhere from 5 seconds to 30 minutes is where our workflows end up being. So the problem that we had with our previous sort of asynchronous work platform was that we basically had started out with this homegrown Python task queue, which was causing problems, like primarily actually because we could only write asynchronous work in Python, which meant we had to duplicate code across across 2 languages. Most of our stack is in TypeScript because most of our work is very full stack. We have a web app for our customers. But we wanted to be able to share some of that business logic with some of our asynchronous workflows. So that was a pretty big pain point. Like whenever you had to write something that was not going to finish properly in like a server call, you had to go write it in Python, which is kind of annoying. And we also wanted something that could scale sort of for the next few years. This sort of homegrown, this in-house solution was written at a time where we were like maybe like 8 people and like 4 engineers or something. And the engineering team has been really scaling since then. So at the time we were considering solutions to this, we were probably around like a 20-person engineering org. So we wanted something that could scale more broadly to sort of those developers, as well as to our customer base, which was also rapidly growing at the time. So we wanted something that would scale for at least a little bit without us having to build our own platform team in-house. And one of the results of this, right, was that we also scaled our data analyst team. So we kind of went from 1 or 2 analysts pressing a button a few times, waiting for a workflow to finish, to many analysts pressing many buttons all the time. And so we actually ran into some of those problems with scale, which motivated our investigation into Temporal. So Temporal ended up being a pretty nice solution because it seemed to fit our needs for both orchestrating slow running and long running work, which was kind of nice because we could share the same framework between the two. The idea of workflows as code, I think a lot of people call out, is really compelling to developers. A lot of our workflows just have a lot of business logic, and it's really nice to share sort of writing that the process of writing that with the rest of our code base. And sort of like the main value prop of Temporal, right, is like workflow state management. We didn't have a lot of features in our sort of in-house Python task queue. So Temporal gave us retries, it gave us timeouts, nice UI, and sort of all the other abstractions in particular defined by Temporal gave us a really good toolkit to solve our needs and sort of build more workflows as we grow. So I'm going to hand it over to David, who's going to talk through an example of one of these.
Yeah, so to talk about one of the ways that Temporal helps us orchestrate, I first have to explain a little bit about estimating emissions. Here's one example of one of the kinds of calculations that we might do. If a customer tells us how many employees they have working from home, we try to estimate how many emissions those people are producing in connection with their work. And electricity usage is just one of multiple ways that these people produce emissions while working from home, but we'll focus on that one. And in the end, what we want to do is represent emissions per month per employee for electricity usage. So we do that by chaining together a series of unit conversions, essentially. In this example, we go from work days and square feet of home office space per employee to kilowatt hours per month to emissions per month per employee. So at a high level, we have a bunch of individual unit conversions, and we're figuring out how to chain them together into emissions, two kind of types of data, the unit conversion and the emissions equation. Can we go to the next slide? Yeah, so every time that we enter a new unit conversion into our system, as you can see from the previous slide, like we will always be entering new unit conversions. There's kind of an infinite amount of data that we can add, going to an infinite level of granularity. But every time we do that, we need to perform a variety of actions. We run the data through some checks. We sync some data stores like BigQuery, Parquet files, Postgres databases, and we regenerate the emissions equations, which is itself a multi-step process. And then after those equations are generated, we want to run a series of end-to-end tests, which aim to ensure that the new equations are like reasonable and they're actually working the way that we intend them to. Thinking in terms of Temporal's workflows and activities, and especially like workflows that can trigger other workflows, has been a really powerful way for us to structure and understand and monitor orchestration logic like this that can get pretty complex. And so allow us to extend the functionality without feeling like we're losing control, not able to wrap our heads around it anymore. So by organizing our logic with activities and workflows, we get these solid abstractions, we get the configurable retries and timeouts for each step. We actually think of these things as activities and workflows, and it helps us communicate about them. We get resilience to interruptions from deployments and infrastructure hiccups, which has been really important for us. We deploy very, very frequently, and hooks for observability that we can apply to each step. So yeah, this slide is attempting to demonstrate how Temporal has helped us manage the complexity by providing the robust framework for coordinating all of this interdependent work that gets kicked off when you do something just as simple as committing a new unit conversion. And that's what we wanted to present briefly. If any of this sounded interesting to you, we are hiring at Watershed. And as Sean said, we're working on one of the most critical problems humans face right now, and we're grappling with the challenges of complexity and scale and data quality that come with this problem space. And we're looking forward to using Temporal and increasing our expertise on it over time and taking advantage of all the features they offer. Thank you.